Hello everyone and welcome back to another Universe Sandbox video, and today we're going to be doing another episode of checking out one of your guys' solar systems. So today we have got one system from the user Pluto Neon in Discord for sending in their simulation, and from the name of it, this is going to be interesting. So let's go ahead and search it up and then you'll see what I mean when I say it's interesting. So here we go, look at this. The geocentric model of the solar system. So I think I did a video on this way back in the day. I think I'll have to maybe put some footage of it in this video as well. I don't even know if I have that simulation anymore, but yeah, I'll have to see if I can put some in this video as well. But you're right, here we are. So where exactly are we? We're zooming in. Oh my, whoa, this is cool. Look at this. Look at all the coloured stars. Oh yes. Oh wow, what is all this? How cool is that? Already, but let's actually get onto the reading first. So, this is the closest model I could make of the 14th century geocentric model of the solar system. Contrary to our typical solar system, the geocentric system features Earth as the core of the system and a sphere of fixed stars as the furthest sphere from the Earth. Yeah, so this, back in those days, everyone thought the Earth was the centre of the universe, the centre of everything, and if you thought different, you could face some big punishments for it, if I remember right. Yeah, I think you could even be executed for it. I mean, yeah, if you believed something different back then, yeah, may not have ended well for you. And yeah, science and all that was a lot different than it is now, of course. So yeah, the 14th century, whole different time. So yeah, fixed stars, the furthest sphere from the Earth, right? Core system, and yeah, that is really cool. I like all those stars all colourful in the background. That's really cool. Right, the moon and the sun were considered planets at the time, and they were both believed to be the largest of the planets. Mercury, Venus, Mars, Jupiter and Saturn were referred to as wandering stars, since they appeared to be stars that were consistently changing location in the sky, because obviously they were all moving as well, while the real stars would stay fixed in a constant location and organisation, obviously because as well the main stars in the night sky, because they're so far away, you wouldn't notice anything even if they did move just an inch or whatever. So yeah, really cool stuff. I made each planet glow by using fireworks tool on them, getting the colours and the brightness. Oh, so use the fireworks. Oh, that is some good thinking there. No one has ever mentioned the fireworks or used them. I mean, I haven't used them in ages. I pretty much forget they're in the game most of the time. So I made each planet glow using the fireworks. Getting the colours and the brightness that I wanted was tricky, since there's no option to set those details. It was even harder to not make these planets pull on each other despite they moved and ruined their orbits. Yeah, I remember when I was making this simulation, the Sun and Jupiter were really hard because they kept upsetting everything. But now, in the modern version of the game with the lock feature, you could just lower the mass and keep them the same size. So I think the Sun would be the only difficult one, because it'd be quite hard to get a little star or a pulsar. You probably have to use like a pulsar or something, but we'll see how he's done it. So despite me trying to get their actual orbital periods, I gave the wandering star planets retrograde orbits to explain the planetary retrograde periods in the sky. The Sun, Jupiter and Saturn couldn't hold their hydrogen mass due to their lower gravity, so against my intent they stripped themselves into Chotonian planets, former gas giants that have lost their gas layers. Okay, but their exposed core. The surface of fixed stars was made using more fireworks. Zoom out and see it. Also try land on Earth and turn off the orbit view so you can get a good look at the radiance of every planet and star, and perhaps you can even play the simulation time-lapse as you do so. Oh, we'll have to play it. You can also try landing on the moon or another planet to see what the Earth looks like from there. So here we are. Right, so we can go ahead and close that. So the Earth at the centre of the universe, literally, as we can see here. So back in the 14th century now, very centre of everything was our very planet. So here is the Earth in the very centre. So 1.01 Jupiter masses here. Yeah, he definitely had to make the masses bigger for this all to work. So here is Earth. Right, so obviously the next object out will be the moon, as always, because moon's a lot bigger than everything else, so it'd clearly be closer. I really like all the little firework areas. That's really cool, all those little particles. That is so cool. So yeah, the moon looking good. So there you are, moon. Right, so now head now. So this is where it starts to change. So we have the Earth and the moon like normal, but next up we have got whatever this is. Where are we? Ooh, what is this actually? Interesting. What the heck? A blacked out object. That's rather mysterious, isn't it? What about this one? Another darkened out object. That's rather interesting. Are they all like that? No, they're not. Okay, so oh, this is Mercury, right? Oh, okay. I see what he's done. So he's used this to keep them in place, and then he's put the actual planet around it. So, right, so let's just quickly track back. So we have the Earth, the Moon, and then Mercury was the next object out from the Moon, as we can see here. So here's good old Mercury. Right. Looking good. So good old Mercury, next object out from the Moon. And then next up, I'm guessing it's Venus or Mars. I'm not exactly sure. I can't remember off the top of my head, right? So where are we? Venus. Okay, Venus is next. So that would have been a bright object still. It's one of the brightest objects in the night sky. So Venus, looking good. So next object out. Right, and then it's got to be Mars next, hasn't it? So here we are. Oh, the Sun. Oh, don't forget the Sun. Right, the Sun. Right, so here is the Sun. We've got a huge load of material around it. That's cool. So yeah, he's used a planet as a template for the Sun instead. So there it is, the Sun. Looking good. Right, moving on. So this has to be Mars now. Yeah, here is Mars. Looking good. Alrighty. And then next up, we have got, this will be Jupiter are over here, and then Saturn as the very last object, because Uranus and Neptune were not discovered for a long time after the original planets. So right, that's the Jupiter. Got the green trail, and then lastly we have Saturn, the last planet in the solar system for a long time in history. I mean, yeah, Uranus and Neptune were discovered in, I think it was at the 17 and the 1800s. So yeah, they're way before. Uranus was discovered using mathematics, the first planet with mathematics, I believe. So yeah, all the other planets have been known since like prehistoric times. So obviously Jupiter and Saturn, they're a lot closer, they're a lot brighter, they're bigger, so you can see them a lot easier. But yeah, Uranus and Neptune are way too dim and far out for scientists of those days to locate them properly. So yeah, pretty cool. And yeah, Saturn, the last planet in the last planet ever, basically, because we didn't know anything further out than Saturn. There was no exoplanets, no Uranus, Neptune, no dwarf planets. It was literally just Mercury, Venus, Earth, Mars, Jupiter, Saturn, and the Sun, and obviously the Moon, and that was it. They were the only space objects. So there's the full lineup there. So yeah, pretty cool indeed. Right. So Earth, let's head back to Earth. So let's go have another look at all of the objects. We'll just land in the north here. Right, so labels all off. Right, so I'm guessing is that the Sun? I'm guessing the Sun was the yellow one. So Sun. I put labels on actually. Right, can we? No, labels off, labels on. Right, where are we? Mars is over there. Okay. What's that? Venus. There's the Moon. Okay, so the Moon is obviously the closest thing, the brightest thing there. Very nice. Mercury, the second closest object. Right. I'm guessing that's Jupiter there. I think the green was Jupiter, wasn't it? So there's Jupiter. There's the Sun itself. So obviously the Sun, very, very bright. Biggest object, probably viewable other than the Moon. And then Saturn is... Is it Saturn the yellow one over there? Trying to work out where it is. I think that was Saturn. So, yeah, really cool indeed if we look up. Oh, no, they'll all be in a line, won't they? Right, so let's see where we are. And Earth had all these cool particles around it as well. So, yeah, red was Mars. That was Mercury over there. Or Venus, sorry. Then we had the Moon. Then Mercury was next. Yep, there's Mercury. Right, and then turning around. So, there's Jupiter, as we saw. The Sun. And then lastly, it was I think Saturn was the yellow one over here. Was this Saturn? Yes, it was Saturn. Okay, cool. So yeah, Saturn was the yellow one. So yeah, that was the whole solar system viewable from Earth. Simple as that. Back in those days, that was all of the solar system. So yeah, really crazy. I mean, just looking at the orbits again, that was it. This was how it was thought to be for a long time. There was nothing else. I mean, look how strange it is. Earth at the center of everything. The Sun obviously orbiting the Earth. Turn the labels off. So yeah, the Sun orbiting the Earth. All the planets orbiting the Earth, and then the rest of the stars in the night sky, all surrounding the Earth, and then that was the universe. That was literally it. So, really, really cool stuff indeed here. I mean, yeah, there you go. The whole universe back in the 14th century, for example. That's a lot different than it is now, isn't it? I mean, that is crazy. So, yeah, there it is. Earth. Not at the centre of the universe anymore, unfortunately. So there we go. But now, moving on. He also sent an object in for the last competition video. So that would have been, or it would have been 2 competitions ago. So it was the Habitable Planet with backstory. But he sent the wrong object in, he told me. So we are also going to be putting his object in this video as he requested. So yeah, we're going to be doing that. So he put it in object upload, if I remember right. So whereabouts was it? Just trying to find out where it is, actually. Oh, it was in the competition chat. Okay, so let's go ahead and search it up. So it was his planet, Roy Zodia. So let's go ahead and search it up. So here it is. Right, this is the actual one that he was meant to put in. So we'll put that as the next planet out from Saturn, I guess. Let's face it there. Right, so let's check it out. Roy Zodia. Oh, no, this is another Earth one. That can't be the correct one, surely. Let me quickly just try it again. Maybe it's a simulation he sent, actually. So I think that would make more sense because the original one he sent was a simulation as well. So, yeah, we'll quickly save this file in a simulation instead of a... yeah, right, let's try that. Right, so I've saved it in simulations this time. So, right, let's search it up. Right. Aha, right. This simulation looks like it. Right. So, yes, here we go. Right, this is the world he was meant to submit. So, there it is. Right. So, this is... Oh, my God, this is very interesting. There's a lot of reading. Right, planet Roy Zodia is the secret 9th planet in the solar system. Oi, oi. Located in Earth's orbit opposite to where Earth is, sharing the exact same length of year. So, even more of a sister than Venus's. Making it not habitable in the Earth's sky. Yeah, if it's in theory, if it's completely opposite Earth, that means the sun will be in between them at all times. So actually, what we can do, we can actually do it as an example in the next simulation. Actually, so that'd be quite cool. Right, so it will be located behind the sun. It has a large spherical ring system that acts as a barrier for the planet and creates vast sky rainbows. Due to the particles having prismatic properties, ever wonder why asteroids rarely pass by or crash into Earth, or why aliens rarely come to planet Earth? It's because they favour Roy Zodia. This planet is extremely abundant in crystals and minerals, even on the surface, especially the rare ores and some that don't naturally form on Earth. The planet has 3 moons and 2 submoons. A pink and cyan moon, a retrograde 7-day orbit, and yeah, I'm not going to say their names, I cannot pronounce those. A large submoon resembling a grape with a 24-hour orbit. Okay, are they in here? And I think it's just the planet itself. That's just the planet itself, okay. Resembling a golden moon with white rings as well. That'd be pretty cool to see. And a black moon with season-long orbit. A Titan-like hazy neon green submoon with a dark hidden surface and 12-hour vertical orbit. Okay, all bodies of the Roy Zodia system have their own unique life forms, with the exception of like I said that one, Ceres, due to its atmosphere being poisonous and hotter than Venus. Roy Zodia is home to bulky and short but lightweight humanoids adapted to the strong gravity and atmosphere pressure. Humans can stay alive on this planet, but they will struggle to overcome its high pressures and may even evolve when exposed to its conditions for an extensive period of time. Right. In fact, it is believed that the bizarre humanoids of Roy Zodia are descendants of abducted humans. These beings obtain their nutrition by consuming mineral-rich rocks and soil. Oh my God, right. The water in some areas of the planet is very potable, but in most places the water is poisonous and corrosive, especially in the oceans. The Roy Zodia system was formed and arranged in a manner so bizarre and complicated that people question if this planet was even formed naturally. Yeah, and it's opposite to where the Earth is. How unnatural is that? It is very common for residents of the system to believe that the system was created and organised by a highly advanced alien civilization. Hey, that's cool. Right, what we'll do actually, so we'll quickly close that. We'll lock on to the planet itself, and then we will place it. Yeah, we'll replace the old one because this is the correct one. So we'll replace that. And now we will head to... Oh, it's also got city lights. Look at that as well. Hell yeah. So city lights, but we will head to the good old regular solar system. Go to the enhanced one, why not? So let's go in here, right? Orbits labels on, click play. Right, so Earth, we're heading down here. I'm going to click pause. And now we're going to input his planet into the actual scenario. So here it is. Right, so it goes roughly here. So on opposite sides of the Earth. Now we'll try and get it exactly opposite. So if we look at the Earth, for instance, just to make sure we got the stats exactly correct. So Earth is 1.01 years at the moment. So this is 1.02. So we'll quickly put that to 1.01. Like so. There you go. Right, so that is completely opposite from where the sun is. So yeah, they are polar opposite sides of the sun. So you can see there, I'm still not actually in the correct place. We need to try and actually get it perfect. So like that, I mean, that's close enough. So you can see the Earth is not visible because it is behind the sun. You can just see it's over to the left, I know, but that's roughly what it's like. So perfect opposite side to where the Earth is, and it would obviously orbit there without us ever seeing it because the sun is in between us, and obviously the sun would block out any visibility. Even in this area here, you'd never be able to spot the other planet, Earth, because the sun is just too close. and they're always on opposite sides, so you'd never see the Earth. So pretty cool. I like that. Cool backstory, cool planet, and yeah, just a nice little add-on for today's geocentric solar system. So yeah, awesome stuff indeed. And yeah, massive thank you to Pluto Neon for sending his simulation in. So with that all said and done, guys, though, massive thank you for watching today's video. Hopefully you enjoyed the geocentric solar system. I think that was really, really nice. I really like what he did with the fireworks and stuff. Very nice indeed. And yeah, good to see a geocentric solar system. Really, really cool indeed. Yeah, absolutely excellent. So yeah, there we go. But yeah, if you liked today's video, guys, make sure to hit that like button. Let's see if we can go for 30 likes on today's video. And also subscribe if you're new. Helps on the journey to 20,000 subscribers, guys. But yeah, that all said and done, make sure you have a great day. Stay safe. And I'll see you in the next video. Goodbye.